Hello and welcome to a very special members only Data Management University members only webinar on AI, machine learning, and ChatGPT's role in data management. I am Dr. Marco. I am your host and actually speaker. We don't have a host today because this is pre-recorded only for our Data Management U members. Most of you know who I am. I'm the president of EW Solutions. We've been doing work in data management since 1997. We have over 150 client partners over that period of time. So when I talk to you about AI and machine learning, I really want to focus on how we are utilizing it. The second half of this talk, I'm going to focus on how we're utilizing it in our client programs. This is my background slide. I will not read this to you, but feel free. If you have any questions, you can shoot me an email at dmarco@ewsolutions.com. With that, what am I going to talk about? Well, first thing I want to do is just quickly go over some basics about artificial intelligence and machine learning so that we really understand what these things are and what they're not. There is so much marketing hype behind these that we sometimes lose track of what's really happening in there. I'm going to explain a little bit about neural networks, and then we're going to get into the topics you really want to hear about, ChatGPT and how we can use artificial intelligence and machine learning to do advanced data management, the stuff we're doing with our client partners. So buckle up and get ready for this content. All right, artificial intelligence and machine learning. First off, machine learning is a subsection, a subcategory of artificial intelligence. And when we talk about artificial intelligence, we're talking about machines that respond to stimulation consistent with traditional responses from humans, given a human's capacity for contemplation, judgment, and intention. Basically, a machine that acts like a person. News flash for everybody. Machines do a poor job at this. If you don't believe me, let me give you an example. Think about having a discussion with your spouse. You can give them a particular set of input variables, and on one day get one response, and another day get another response. That's not how a machine works. These AI algorithms would be consistent in their response because that's how a machine works. Humans and their ability to reason and think, it's just something machines don't mimic all that well. That's why we like to joke that, hey, AI, it makes for amazing movies. Who does not like the Terminator series? I know I've seen them all. But really, this whole concept of real intelligence, it's intrinsically human. And it really isn't well mimicked by machines. However, it does have a tremendous amount of value, and there's ways we can utilize AI, in particular machine learning, to really make a difference in our data management program. So let's keep it going. So when we talk about machine learning, we are talking about a method of data analysis that automates analytical model building. And again, it's a branch of AI. And really, when we talk about machine learning, what are we doing? We're using models, neural networks, decision trees, and natural language processors to help us run a business, to help improve a federal agency, to do a task that normally would be very difficult to do. So when we look at AI and machine learning, it can be used in so many different ways. This slide here is a lovely walkthrough of some of the common things, surgical robots and personal assistants and all this kind of stuff. I'm not going to walk you through it because I want to get to the data management pieces, because this is Data Management University, so I should certainly talk about data management. All right, quickly, let's hit neural networks. This is the most complicated slide in this deck. If you stay with me, I promise you it'll be worth it. But I'm going to summarize what a neural network is in machine learning and AI. First up, neural networks is a network of artificial neurons programmed into software that simulate the human brain. So even concepts like neurons that we use in AI, it comes from the study of the brain. So the big thing here is there are three layers of neurons: the input layer, the hidden layer, the stuff we don't want people to know about, and then the output. So when we talk about a neuron, a neuron receives one or more signals. They're called synapses. Same thing we call the brain when it fires, when its neurons fire, we call them synapses. Same thing here. Don't let that complicate you. Don't let that intimidate you. All in synapses in AI is input, some sequence of numbers, most likely. And it performs some calculations. It does something. That's that hidden layer. And there could be a whole lot of them. And then it sends a synapses or output to neurons deeper in our neural network. So this is like any program anybody's ever written. What happens in a program? There are inputs, then we have some processes, and typically there's an output. Same thing here. Synapses is the sending and receiving of the data. In addition, and this is the real trick of machine learning, there'll be a weight attached to many of these synapses, and that's really important. The weight says how important that synapses is, and that weight is typically how we tune these models. Anyway, the first, in a typical neural network, the first layer of neurons will receive inputs like images, video, sound, text, whatever we're building this for. And then it will begin the process of converting them into numbers. Normally, we need to use numbers to really do some heavy-duty processing. By adjusting the weight, that's the primary way neural networks are trained, typically. Now, common neural network uses that we would be aware of, your smartphone. If you were to pull up your smartphone, ever notice when you take a picture, it'll put a box around the faces, or at least what it thinks are the faces? Well, that's a good example of a neural network. Phone text suggestions, when we're writing texts or emailing people, now I have to tell you, this is one that annoys me. I can't tell you how many times that neural network for text suggestions have screwed up a text or two, but it's getting better. I've noticed that. Also, if you've ever used online translation tools like Google Translate, certainly this is an example of a neural network. May I say that I think the #1 use of Google Translate is by middle schoolers who are messing around and want to hear it screw up different things. If you can't tell, I know what it's like to be a parent of a middle schooler. Anyway, let me continue. All right. What are some of the common approaches for machine learning? And I'm sharing this section, again, a little bit technical, because it'll help us when we look at ChatGPT. That's why. And some of the ways that we're using machine learning in data management. There are basically 3 major approaches for machine learning: unsupervised learning, reinforcement learning, and supervised learning. I'll bury my lead. The supervised learning is pretty much the most exciting, but all of them have use. Many large neural networks, like ChatGPT, it will use a combination of these. I wouldn't be shocked if all of these are used somewhere within that massive neural network, but more on that later. Large learning modules, LLMs, are machine learning modules trained extensively on extensive contextual data with all kinds of natural language processing, and they perform these tasks much like question and answering. They'll do machine translation. They'll do sentiment analysis. What's sentiment analysis? Maybe not everyone knows. It's when it's kind of, think of like the man on the street interview where you ask somebody, hey, do you like this color? You know, what's your favorite color? And say, oh, my favorite color is red. Well, it's very, oh, no, what your favorite color is red. It may go in there and it would actually parse that to understand the question and then really understand, oh, your answer is red. Well, there are a whole bunch of shades of red. So you could see where that kind of analysis could be maybe a little bit more complicated. So where sentiment is analyzing people's opinions, which sometimes are not all that black and white. They're not binary. Anyway, keep in mind, sometimes on big neural networks, we'll use unsupervised or reinforcement learning as a feedback loop, a way to improve our supervised learning modules as well. So anyway, let me get into what these are. When we talk about unsupervised learning, all we're saying is our model will learn from test data, and that test data has not been labeled, classified, or categorized. Unsupervised learning identifies commonalities in the data and then reacts based on the presence or absence of such commonalities in each new piece of data. That's what unsupervised learning is. It's looking for commonalities, both common things that are present and common things which are not present. So, reinforcement learning, what is this? It enables an agent to learn in an interactive environment, typically by trial and error, using feedback from its own actions and experiences. Here's the big thing with this model. Reinforcement learning. The model doesn't have the answer to the question. It is going to look at something and it is going to try to use trial and error to learn something. And based on the results, it will try to figure out if it has learned something that's true or something that's false. Even false conclusions are valuable in a learning model. But the big thing here is this model doesn't have the answer, so it's strictly dependent on the model's analysis itself. All right, supervised learning. If you've really been tracking this, you probably realize there's one other combination left. It's where you have input variables and an output variable, probably variables, and you use an algorithm to learn the mapping function from the input to the output. The goal is to approximate the mapping function so well that when you have new data, whatever that might be, you can predict your output data. And here's the big thing. This is called supervised learning because the model itself has a training data set with the correct answer. So you kind of think of it like a professor sitting next to the algorithm saying, no, you didn't get that right, or yes, you did get that right. Yeah, I think I just had a flashback to my master's days. But anyway, let me keep going. Supervised learning is using label data with historical examples. Again, your answer set. This has had tremendous success, and it's really a true disruptive force in our industry. And this is just an example I've walked you through, and this is really just the main cut sheet of here. Take this sheet, cut it, put it up in your office. It's a great way to summarize what I just spoke about of supervised learning, unsupervised learning, and reinforcement learning. One sheet that summarizes basically everything I just said. But I hope it doesn't say it quite as interesting. Anyway, ChatGPT. This is what you really want to learn about. All right. So first off, ChatGPT was created by OpenAI. When you hear OpenAI, you think, oh, this must be a nonprofit. No, it's for profit. Come on, folks. You knew it would be for profit. Here's the thing. We don't know how much it costs to build ChatGPT, but it is estimated of people who really understand this industry and looking at some of the books of OpenAI, it has to be somewhere north, probably quite a bit north of $100 million just to build the initial iterations of this. It has to be somewhere north of it. That's our best guess, and possibly many times more. It is estimated that ChatGPT costs over $700,000 a day just to run. Wow. Bet you didn't know that one. That is a staggering amount of money just to run this thing, because the neural networks are so large and they require so much processing power that they may have to replicate these things across many servers, and to give that good response time that we see when we utilize it. So it is a really expensive product to maintain, north of $700,000 just to run it each day. Learning point, in case you haven't figured it out, massive neural networks like this are very expensive to build and run. They just are, because there's so much complexity, and that's something that really leading AI people and machine learning people are just racking their brains. How can we somehow control the costs of these things? Because that cost is just too high in processing power and hardware. All right, a little bit of more information. OpenAI lost over $500 million in 2022. Over $500 million. Staggering. How could they do this? Well, I have the answer to that. In 2019, Microsoft invested, Microsoft's not giving anybody anything. They invested $1 billion into OpenAI and then followed it up with 10 billion more in 2023. That's how they're able to withstand these kind of losses, because ChatGPT, we've all heard of it. It's being used everywhere. It is an opportunity to really get on top of the whole generative AI movement that we see. So let me continue with ChatGPT. So first off, let me describe more of what it is. ChatGPT, and at the time of this recording, they're on GPT-4. We already know they're coming out with 5. They've been working on it. It is an artificial intelligence large language model, LLM. And most likely, it's a whole bunch of large language models. I wouldn't even be able to guess how many, that can mimic human-like speech and reasoning. And it is, out of all the different AI solutions we've seen that tries to mimic human speech, this is the one that sounds the most human out of all of them. And it does this by training on just a vast library of existing human communication, classic works of literature, and major portions of the internet. That's a little scary to me. I don't really know that I want my computer talking like the internet, but that's a different talk for a different day. Let me continue. It really is quite sophisticated at mimicking prose, art, video, or audio, which is something that's quite difficult to do. And it's really the quality of GPT's output that's made it so publicly known and garnered it so much publicity. It can answer you questions like, hey, explain quantum computing in simple terms. Yeah, that's hard. Hey, do you have any creative ideas for a 10-year-old's birthday? You know, that's a good thing. How do I make an HTTP request in JavaScript? It actually gives pretty darn good answers to these kind of questions. And it has advanced capabilities. And here's one of the big ones. It actually remembers what the user said earlier in the conversation. That's big. You don't see this from many of these large language models where they remember the things the user said earlier in the conversation, because this is more human-like, right? If you and I are having a conversation and we're talking for an hour or two, we'll remember what was said early on, because that could have an impact on our current conversation. It also allows users to correct previous statements they've made, and also declines inappropriate responses, or requests. That is some capability that's been added in there. Think of it as a governor switch to try to control some of the more dangerous applications of ChatGPT and other similar applications. Keep in mind, it has some limitations. Some of its responses are just flat incorrect. There was an attorney who, wasn't all that wise and used it to write a brief. Turned out the cases cited in the brief were wrong. He or she, I don't know who it was, got in big trouble for that. Also, it may produce harmful instructions. It told a user how to construct a Molotov cocktail. This is not a good thing, and that's why we need to decline inappropriate requests. And that would certainly be inappropriate. Also, as of this recording, its knowledge is limited. ChatGPT is limited to just the world as it was in 2021. It doesn't know the Kansas City Chiefs won the Super Bowl last year. It doesn't know that my favorite football team, the Chicago Bears, is not looking all that good at the time of this reporting. It doesn't know that stuff. It doesn't know recent events. Really, it only knows up to 2021. So, ChatGPT. If you want to be a subscriber, first off, it has a free version. But if you want to be a subscriber and get all the plus features, $20 a month. I hope every one of you are thinking, hey, this thing costs almost $1 million to run every day. We're not going to make that up at $20 a month. And no, you won't. So they know they're running this thing for a loss. They know it, and it's going to continue running like that for a little bit. Uses for generative AI. It uses generative AI, but also competes. It's not the only fish in the sea. There's a whole bunch of them. Google Bard, Baidu's Ernie, DeepMind Sparrow, which is owned by Alphabet, and Meta's BlenderBot, and hundreds, if not thousands more that are being baked right now in Silicon Valley and Research Triangle and a whole bunch of other places. Generative AI, it just uses these incredibly large neural networks. And we don't really know, is ChatGPT unsupervised learning, reinforcement, supervised, some combination, or even something new? I would say with a certitude, as a best guess, I have to imagine it uses all three of our known approaches and probably some new stuff as well. So I've given you the background on AI and machine learning. I've talked to you about ChatGPT. Let's look at how we can use these tools and technologies in data management today in our programs, because that's what I'm interested in. People call me up and say, hey, Dr. Marco, we're building a data governance program that needs full data quality and full metadata management, and we're starting from the ground up. How do we do it? And we're, a Fortune 50 company. That's a complex, difficult problem. And if we can use these technologies and approaches to make our life easier, I am all for it. And a little bit of hint, we can. All right. Let me give you an example here. One of the common tasks we have is identifying the different processes and reports that we have within an organization. Any large federal agency or global 2000 company is going to have just staggering amounts of data, typically in the petabytes. Lots of times this data is incorrect, misunderstood, or misleading. And when it is, when we use AI and machine learning for analytical reporting, it fails. When our data scientists try to pull our data and make some really good decisions, they struggle because our data is in such bad shape. So the data is not only inaccurate, misunderstood, and misleading, but we have boatloads of redundant processes. In my professional experience, having worked in this field for more time than I care to state, I can tell you that what I see, most companies have sevenfold needless data redundancy. Some data redundancy is good. When we pull out data from our source systems, pull them into a data warehouse or a data lakehouse, hey, that can be great for our analytical decision making. I'm not talking about that kind of redundancy. I mean needless redundancy. We're just redundant because we don't know how to manage our data. In my experience, sevenfold, 700% redundancy. So if you're a company and you have 7 petabytes of data, you can probably do everything you do today with the same backup and recovery with 1 petabyte. That's my experience. Anyway, machine learning holds incredible promise in this area. I'll give you a real life example. Client partner we had, Micron, Fortune 300 company. We had a good quality data governance tool in there. They had over 6,000 ETL jobs. Extract, transform, and load. That's what an ETL job is. We used a machine learning enabled metadata management tool. And we discovered that over half of their jobs, over 60%, were dormant in one way or the other. They're pulling from data sets that don't even exist. And these suckers are running constantly throughout the enterprise. We're able to remove that redundancy and really cut down the complexity and depth of that IT environment. This is a small example of how we can use machine learning to identify and reduce our IT footprints. Any CDO will tell you they want to reduce their IT footprint. And AI and machine learning, this is the stuff we do to make that a reality. Most companies have thousands, if not tens of thousands, of meaningless, redundant, and dormant SQL Server databases just sitting all over their network. Most reports that have been built at a company are just not even used anymore. We had a client partner recently where when we used AI to look at their reports, we found over 80% of them were dormant. So let's shut that stuff off rather than keep reloading these reports all the time. It's just crazy. So this is a wonderful application for AI. All right, let me continue. Anybody who's built the data stewardship program will tell you it is hard to organize all these data stewards and get them to do all these manual tasks that it just takes, hey, defining looking at your critical data elements and building out definitions, creating valid values. Hey, which ones are attached to which business terms are attached to what data elements? These are big tasks, especially when an organization has over 10,000 applications. And if you work at a large federal agency, I'm talking about you. This is classic. And petabytes of data, there's just no way to have people manually go through this. Machine learning can and does ease this burden when you know how to use it. That's the trick. Most don't. Anyway, most data governance software providers gives the stewards the ability to identify PII and any business term using AI and machine learning. PII, I assume you know what this means, personally identifiable information. What does that mean? A lot of times what we'll do with one of these tools is we'll come in and we'll say, oh, okay, here's social security number. And we'll say, hey, this is PII. We will attach a table column that we feel best represents social security within our agency or corporation. And then based on the pattern matching, the data matching, the format matching, we'll then use machine learning to go against all the other databases that we've scanned into our environment and then automatically generate a list of, hey, these are the fields that look like PII. I'd say I did this not long ago, 6 months ago, with one of our client partners, and it was staggering. Their IT department thought, oh, we have a list of the PII within our main system. They had a list of maybe 30%. It turned out lots of developers were hitting the source system and duplicating those files and those database tables. They had PII spread everywhere with no control. I mean, talk about a lawsuit and a data breach waiting to happen. This is where we can use AI and machine learning to automatically identify this stuff, start masking it, and then start getting rid of it. All right, let me continue. This is one of the things that most excites me. It's something that I am moving forward with my client partners on, and that's using machine learning to auto-tag data assets with metadata. What do data stewards use most of the time? For those of you who are seasoned data governance professionals, you know 80% of what a data steward uses is metadata. They're defining metadata. When we talk about valid values for a business term, like social security number, like date of birth, like customer type, valid values are metadata. The definition is metadata. Having data stewards hand document all this, it's a lot of time. Trust me, I've been down this road dozens and dozens of times. What is exciting is that, and to try to capture metadata on 10,000 plus applications, good luck. It's hard to do. What I'm excited about, and we're working with entities right now doing this, is using AI to take data, and in particular, what excites me is going after unstructured data, images. Images are the bane of so many companies' existence, whether you're a manufacturing company, whether you're a pharmaceutical company, certainly in the federal government. My goodness, this is all over the place. Using it to auto-tag metadata. I will tell you right now, the goals I'll set, can we just do 40%? Can we auto-tag and get correct 40% of these images with metadata? To do that, we have saved 10,000 plus data steward hours. That's real cost savings and speed. Even more than the cost savings, I know that's what excites you, but to me, it's the speed of having us compete better as a business, as a federal agency. And we are using multiple ML models to do this. And to really automate a lot of this work that data stewards used to do. Can we automate all of it? Oh gosh, I wish we could, but I have hope that one day we can do more and more and more. All right, there are many, many more AI and ML applications just like this one, but I only have so much time. Let me proceed and wrap this thing up and talk a little bit about ChatGPT. Making data governance software interactive. There are data governance vendors who are looking at ways to integrate ChatGPT right into their product offering. For example, right now there's a data governance vendor who has integrated it into their offering. Their software loads analytics, which are reports and visualizations, and has data stewards enter metadata on them. They've linked ChatGPT within their application to allow users to ask questions about their data. Here's some screenshots of their software. And one of the learning points here, and this is DVSum, they're the ones who are doing this, at least that I see, but I know other vendors doing it as well. Here's the learning point. This is the tip of the iceberg. More of this is coming. We're going to see it all over the place within our software packages. All right. In the final analysis, let me wrap this thing up. AI and machine learning is not a magic bullet. It's a little bit like the magic snail. It takes a little bit of time to implement it and to build it and to do it right. It's not something you can do a day, a week, or a month. I'll give you an example. I had a major pharmaceutical company ask me about, hey, David, we have a 50 petabyte problem. How do we solve it? And certainly in my proposed solution, we were using AI and machine learning heavily. But I shared with them, it will take time to implement. Just like it took you 100 years to build this problem, it's going to take us a little bit of time to fix it. It won't take 100 years, but we're not going to just be able to throw these algorithms out there and have it happen. We need to find the right classification schemas. We need to find the right engines, and engines that can work with our schemas to really get it done right. So it's not a magic bullet. It's like a magic snail that costs a lot of money. But compared to the problem, to me, it's infinitesimal. AI and machine learning, it's expensive, and you need experts who are experienced. It's one of my pet peeves in data governance and data management in general. So many organizations, especially federal agencies, they bring in rookies. They bring in people who've never really done this, especially at an enterprise level, and you're going to bear the fruit of that result. That's why you hear statistics about data management programs. Most companies fail on their first 5 to 7 times. That's because they realize you need people who really do this. This is all they do as a career, not something you do as a sidelight. I better be careful. I don't want to wind myself up because I could spend an hour on that topic, but this is not easy. This is top of the food chain skill sets it takes to do this right. So foundational data management capabilities are a must. If you don't have the basic foundation down, AI and machine learning isn't going to fix it for you. So you better get your fundamentals right. Implementing this stuff is the bleeding edge of data management. So sometimes you have to manage the unknown a little bit, especially when you talk about auto tagging, using a ChatGPT. You're out on that bleeding edge with some of that stuff. Some of the other applications like the automatic PII identification, redundant data identification, redundant process application, we've been doing that for a little bit. But at one time that was the bleeding edge too. Some of this other stuff, just know there's going to be some unknowns. With that, I believe, as a 30-year practitioner of data management, this is all I do. I have worked on over 70 data management programs in my consulting career. I will tell you, all of the ones I work with now, if I have anything to say about it, you leverage AI and machine learning, because it is absolutely, it's not the future, it is the now. And it helps our programs be so much more successful. With that, I'm going to tell you that you do this stuff right, you do it methodically, focused on the fundamentals, you will achieve absolutely amazing results. With that being said, I will let you go in a moment. If you need any help with your program, you can email us at info@ewsolutions.com. We have all kinds of great training and all kinds of great consulting services in this area. And I'm thrilled as president of Data Management U to also give you this members only content. If you like this, let us know, because I'll do more of it. Take care, and I want you to have an amazing day. Bye-bye.